All right, this is me doing the practice test for Calculus 1, sections 2.1 through 2.3. I hope you get to watch this video before the test on Tuesday. So, numbers 1 and 2, you're asked basically to do the same thing. Determine all x values where you cannot find a derivative. If you recall from your notes from chapter 2, section, I think it was 1, there are 3 different times that a function does not have a derivative, and those are at a sharp corner. Those are where there's different left and right derivatives. Derivatives meaning slopes. And the third time is when there is a vertical tangent. So if you are asked to explain each answer, you're going to give one of these 3 reasons. So I can see right here A is not differentiable, so that would be one of the places where it's not differentiable. And the reason for A would be because there is a sharp corner. That's sometimes referred to as a cusp. If you've never heard that before, a cusp is another way in mathematics to refer to a sharp corner. And then points C and D, or C and B would be because of reason number 2, different left and right derivatives. This from here has a different slope than this does. This is a positive slope. This is more of a 0 slope right there. That would be a 0 slope. That would be a positive slope about a point C, so they're different slopes. You can also tell different left and right derivatives typically means that it's not continuous there. And those would be the only other points. This point D and F have a slope of 0. The tangent line there would have a slope of 0. That would be a horizontal tangent line, which is another question later on in the test. E is just your basic, it's a negative slope, and there's no problem with that. So now when we go to number 2, we're looking for sharp corners. So I just go through and say, where are all the sharp corners? Well, there are sharp corners at B and C. Those are the only places there's sharp corners. And then I notice F and E, 2 different left and right derivatives. Okay, and then there's one more point, point G. If you draw the tangent line through there, point G is the third reason it has a vertical tangent. So again, when you're deciding whether something is differentiable, all it means is there a derivative at that point or points? And there are only 3 reasons that you would ever say no, they're right here. So that's all you need to answer questions 1 and 2. All right, so now we're on numbers 3 and 4, and they're asking to use the definition of the derivative. On the actual test, you won't actually be asked to use the definition of the derivative, but you do need to be able to recognize the definition of the derivative. The definition of the derivative, we've already had a short little quiz on. This is the definition of the derivative. This is how you found the derivative to start. Okay, and then we learned the shortcuts. So I'm just going to go over using the definition of the derivative on numbers 3 and 4. The main thing that you'll have to do on the test is identify that this is the definition of the derivative. So I'm going to do number 3 on a separate sheet of paper over here. So problem number 3, my function is f of x equals 3x minus x squared. And if I'm going to find this derivative using the definition of the derivative, I start by writing f prime of x is equal to the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. So now, finding this, if you recall, is the hardest thing we have to do. This says take my function, right there is my function, and replace both of the x's, any of the x's, with x plus delta x. So this will look like 3 parentheses, x plus delta x, minus that x becomes x plus delta x squared. So f of x plus delta x looks like this. Note it is the same as the function, only both x's have been replaced with x plus delta x. Now from that I have to subtract the whole function in parentheses. And then on the bottom, I still have delta x. One thing I forgot to write that I need to make sure I write, the limit is delta x goes to 0. Don't skip that step or leave it out. Okay, now what I'm going to do on the top is get rid of parentheses. First of all here, if I FOIL that, foiling just that, it becomes x squared plus 2x delta x plus delta x squared. Then I'm going to distribute the negative. I'm also going to distribute the negative here and distribute the 3 here. So my next step will be the limit as delta x goes to 0. On the top, I'm going to have 3x plus 3 delta x. Next, I'm distributing this negative towards all of these. So minus x squared minus 2x delta x minus delta x squared. And then I distribute the negative here, minus 3x plus x squared, all over delta x. Now something really nice happens here. Pretty much everything cancels. So the 3x and negative 3x cancel. The negative x squared and x squared cancel. And the only thing I'm left with, each of them have a delta x. So what I'm going to do in my next step is I'm going to factor out a delta x from each term on the top. So if I get rid of a delta x there, I have a 3 left. If I get rid of the delta x there, I have a minus 2x left. And if I get rid of one of those delta x's, I have 1 left. I still have the delta x on the bottom, which thankfully cancels with the one I just factored out. Now what I can do is I can put 0 in for that delta x. So I'll end up with 3 minus 2x as my derivative. Okay, same thing for number 4. I'm going to use exactly the same formula. My function this time, f of x equals the square root of x. The derivative, f prime of x, is the limit as delta x goes to 0 of f of x plus delta x minus f of x all over delta x. All right, so now this is taking my function and replacing the x with x plus delta x minus the function itself all over delta x. In this problem, we had these at the beginning of the year when we were dealing with limits. We multiply the top and the bottom by the conjugate of the top. So we're multiplying the square root of x plus delta x plus radical x on the top and the bottom, and I guess the biggest mistake I see students making is not multiplying it on the top and bottom. And if they do to start, they somehow drop this off somewhere. So when I multiply the top two, I just need to use first minus last. So now I'll be taking the limit as delta x goes to 0 of radical x plus delta x times itself is x plus delta x minus radical x times radical x is x all over that stuff on the bottom, which I never multiply out. So then on the top, the x and the negative x cancel. I just have that, and that'll cancel with that. So what I have on the top is a 1. Now I can put 0 in for just the delta x. So on the top I have a 1. And on the bottom, I have, this just becomes radical x plus another radical x. So I have 2 radical x, and that's my derivative. Okay, and again, the main thing is you're not going to have to do this process, but you have to recognize like that this is f of x plus delta x. It'll be a multiple choice question on the test. All right, back to the test. Now we're just going to start using the rules to find the derivatives. So when I just use the rules to find the derivatives, some of these should be really simple. Number 4, we are asked to use the power rule as well, so I'll do that. So first of all, I'm going to rewrite that as x to the 1/2 power. And then using the power rule, I'm going to multiply by 1/2. You multiply by the power. So f prime of x will be 1/2 times x to the, and then I subtract 1 from that power, which gives me negative 1/2. That is the derivative. Now I have to make it look pretty. So I need to get rid of negative exponents. So f prime of x equals, that needs to go on the bottom. The 2 is already on the bottom, so the 1's going to stay on top, and the 2x to the 1/2 is on the bottom, and I'm done. There's my derivative. So this one's really nice because all you're doing is using the power rule and the sum and difference rule. So the derivative f prime of x would be 3x squared plus 8x, and then the derivative of negative 3x is negative 3, and the derivative of 56 is 0. Okay. Okay, number 6, you're just going to write it, first of all, as x to the negative 3. Then the derivative, f prime of x, you use the power rule. You multiply by the power, so negative 3. Subtract 1 from the power makes it negative 4. And f prime of x is negative 3 over x to the 4th. The negative 3 is fine. The only thing that has to move to the bottom is negative exponents. All right, 7 and 8 are very similar to each other and to number 4. The first thing you have to do is rewrite x to the 4th power as x to the 1/4 power. And now the derivative, f prime of x, I'm going to multiply by the first number, so 1/4 multiplied by the power. Subtract 1 from the power, it becomes x to the negative 3/4. So now when I rewrite that, I just need to move that negative power to the bottom with the 4, so it becomes positive. So the derivative will be 1 over 4x to the 3/4. It is not necessary to try to write that back in terms of a radical. Just leave it like that. So number 8, we're going to write it as x to the 1/3. We're going to multiply by the 1/3 power to take the derivative and subtract 1 from the exponent, so it becomes negative 2/3. So now when I rewrite that, that negative power goes on the bottom with the 3 and becomes a positive 2/3 power, and I just leave it like that. All right, so find dy over dx. Well, all they're asking for is the derivative. Dy over dx, remember, is just another way of saying y prime or f prime of x. So y prime, and some of you might look at this and say, well, I have to use the product rule. Well, you don't, because you can use the constant multiple rule. This 6 is a constant being multiplied by a cosine. The only time you have to use the product rule is if you have you would have 6x times the cosine of x. So here I can use the constant multiple rule, which says you just leave the 6, and the derivative of cosine is negative sine of x. And notice I put it in parentheses so I don't think it's 6 minus the sine of x. Okay, and then I can leave the negative 2, and the derivative of sine of x is cosine of x. So the way I clean this up, I make it look a little nicer as I take that negative and put it in front of the 6. So y prime is negative 6 sine of x minus 2 cosine of x, and I'm done. Okay, for this one I have two options. I can FOIL it out and use just the power rule, or I can use the product rule. Either way is going to work. I think I'll FOIL it out. So f of x, I'm just rewriting it. I'm not taking the derivative. If I FOIL this, 5x cubed times 3x squared is 15x to the 4th. And then multiply the outer, I get minus 10x cubed. And the inner is plus 3x. And the last is minus 2. All right, so then I can just, there's no like terms, so now I can just take the derivative using the power rule. So that would be 60x cubed, and then minus 30x squared, and then plus 3, and there's your derivative. All right, so now let's move to the other side. And the other side, we've got y equals x squared secant x plus 4x to the 5th. So this derivative, what I want to do is I want to use the product rule on this part, because there is an x squared and a secant x. They're being multiplied, both has an x, and here I'm going to use the power rule. So y prime, the product rule, remember, is first times the derivative of the second plus second times the derivative of the first. So x squared, and the derivative of secant x is secant x tangent x. I will have the derivatives of the trig functions written on the board for you during the test. Okay, now plus the second, which is secant x, times the derivative of the first, which is 2x. And then the derivative of 4x to the 5th is 20x to the 4th. Now, it may not look like you have to clean this up much, but you should. Sometimes your book will factor stuff out of these. It's not really necessary. This term you can leave like this, x squared secant x tangent x. But this term you want to write the 2x in front of the secant x. That way you don't think you're taking the secant of the 2x as well. And then the 20x to the 4th. So the only thing you're doing is writing this in a different order, and there's your derivative. All right, now we're looking at number 12. That was number 11. And we're going to have that on the next video.